Hi everyone. In this video, I will do some problems from the homework. Let's first take a look at number 3. Number 3 says to determine whether the mean value theorem can be applied to the given function on the given closed interval. So to determine whether the mean value theorem can be applied to this function, let's recall what are the conditions of using the mean value theorem. If we look at our notes, to apply the mean value theorem, the function has to be continuous on the closed interval and has to be differentiable on the open interval. So if this function fx is continuous from -1 to +2 and is differentiable on the open interval from -1 to 2, then that means we can apply the mean value theorem to this function. Now the question is, how can we know this? How can we know whether the function is continuous and differentiable? There are two ways we can do this. Okay, the first way is if we can graph the function, and then we can know this information from the graph. So if we do this way, okay, let's first graph this function and then look at the graph and to see if the function is continuous and differentiable from -1 to +2. So we can say when x is from -1 to +2, the function is not continuous everywhere between -1 and 2. Why? Because when x equals 0, the function is undefined. So according to the definition of continuous, okay, the function is not continuous on the closed interval, right? Because it is not continuous at 0. And also the function is not differentiable. Why? Because at 0, the tangent line of this graph when x equals 0 is a vertical, and we've said when the tangent line is vertical, the derivative is undefined because the slope will be undefined. Therefore, the function is not differentiable. Therefore, since the mean value theorem cannot be applied, so we couldn't apply. Therefore, we couldn't find this C. So the answer is NA. Okay. Now, what if we don't know the graph? If we don't know the graph, the second way to determine this is to use the method I showed in my previous video. We consider what is the domain of the function, and we consider what is the domain of the derivative function. Okay, let me do it here. Well, so the function is to see whether this function is continuous on the interval from -1 to 2, we need to determine whether this function is defined on this closed interval. since the domain of this function is every number except 0, because when x equals 0, the denominator will be 0, so the function is undefined. Okay, and then because 0 is between -1 and 2, therefore the function is not continuous on this closed interval. Okay, then to see whether the function is differentiable, we first find what's the derivative function. So we're going to take the derivative of this function. Here we can do this by using the quotient rule. Minus the derivative of x times x plus 6. So the numerator we have the derivative of x plus 6, that's 1. 1 times x, that's x. Minus the derivative of x is 1. 1 times x plus 6 over x squared. So we have a -6 over x squared. Okay. The derivative function is a -6 over x squared. And what is the domain of this function? The domain is the same as the original function. The domain is every number except 0. Since 0 is contained on this open interval, therefore the derivative function is not defined. It's not defined on this closed interval. On this open interval. So the function is not differentiable. Okay. If 0 in this problem, if 0 is not contained on the interval, say if the interval we're given is from +1 to 2, then in this case, the mean value theorem, it can be applied. Okay. All right. So let me do another one. Okay. Number 5. Okay. Let me do number 5. Now the function is fx equals 2 sine x, and the interval we're given is from 0 to pi. Okay, between 0 and pi, we can see that the function is continuous, right? From the graph, we can see that the function is continuous and is differentiable. Why? Because the graph has no sharp corner, and on the graph we don't have a point where the tangent line is vertical. So a function is differentiable and is continuous. Therefore, the mean value theorem, it can be applied. And then to find what the c is, because f prime of c equals f of b minus f of a over b minus a, right? And here a equals 0, b equals pi, because this is the closed interval we're given, and the function is 2 sine x. So f of b equals 2 sine of pi. Sine of pi is 0. So 2 times 0 is 0. And f of a equals 2 sine of 0, which is also 0. Therefore, f of b minus f of a over b minus a equals 0 minus 0 over pi minus 0, which is 0. And the derivative of the function is 2 cosine x. So now we need to find a point C such that 2 times cosine of C equals 0. And the C is between 0 and pi. It's between 0 and pi. So in trigonometry, we said that between 0 and pi, when x equals pi over 2, then cosine of x will be 0. So the answer is c equals pi over 2. Okay. Okay. Let me do another one. Okay. Number 7. So on number 7, to see whether the function is continuous, we consider what's the domain of the function. So this function I can write as x squared. Okay, I can write it as the cube root of x squared. Now, since this is a cube root, so x can be any numbers, can be positive numbers or negative numbers or 0. So the function is defined everywhere. Since the function is defined everywhere, then the function will be defined on this closed interval. Therefore, the function is continuous. Okay, the function is continuous. So the first condition is satisfied. Now let's take a look at the second condition. To see whether the function is differentiable, first we need to know what is the derivative function. So I take the derivative of the original function, and to get 2 over 3 times x to the power of 2/3 minus 1, that is negative 1/3. And the derivative of 4 is 0. Okay, so the function will be 2 over 3 times the cube root of x times the cube root of x. Okay, for this function, the domain will be every number except 0. Right? X cannot be 0. And because 0 is contained on this open interval, so this derivative function is not defined everywhere on this the derivative function is not defined everywhere on this open interval. On this open interval from negative 27 to positive 27. Therefore, the function is not differentiable. So the function is not differentiable, and since it's not differentiable, we cannot apply the mean value theorem. All right. For number 8, okay. For number 8, the function is fx equals 9 minus the absolute value of x minus 9. When x is from 0 to 18. When x is from 0 to 18, we can see the graph is a continuous because there's no break, right? However, the graph is not differentiable everywhere because we said at this point, at the top of this point, the derivative does not exist because at this point we can draw two different tangent lines, right? So the derivative is not unique. Therefore, for this function, even though it's continuous on this closed interval, but the function is not differentiable. So again, the mean value theorem cannot be applied. Okay, let me do some other problems. All right, let's take a look at this one. At 9:13 a.m., a sports car is traveling 39 miles per hour. 2 minutes later, the car is traveling 86 miles per hour. The mean value theorem guarantees that at some time during this 2 minutes interval, the car's acceleration is exactly 8 miles per hour squared. And we are asked to compute the value of A. So what does this problem mean? So here we are given since we are talking about the velocity of the function at different time, so we have a function, let's call that v of t. This function gave us the velocity of the car at time t. So here we assume that the function is continuous and is differentiable. So we have two different times. One is at 9:13 a.m. So at this time, the velocity of the car is 39 miles per hour, and 2 minutes later, the velocity is 89 miles per hour. Okay. So we assume, since we assume the function is continuous and differentiable, okay. Now, if we connect these 2 points, we can have a we can have a second line, right? And this second line, we can find what is the slope of the second line. So the slope of the second line is equal to the difference of the function value over the difference of the input value of the difference of these two times. The difference of these two times is 2, because the second time is 2 minutes after 9:13 a.m. So the difference is 2 minutes, and the function value are 86 and 39 respectively. Therefore, the slope is 47 over 2. Okay, 47 over 2. Now, the mean value theorem tells us when the function is continuous and differentiable on this interval, then at some point between t1 and t2, I can find a point, and at that point, the tangent line at that point will be parallel to this second line. So the slope of this tangent line also equals 47 over 2. And the slope of this tangent line is given by the derivative of this function at this time. Let's call this time as a t3. Since this function is the velocity function, so the derivative of the velocity function at this time t3 will be the same as the acceleration function when t equals t3, because we said when we introduce the derivative, we said when we take the derivative of the velocity function, we can find the acceleration function, and when we take the derivative of the position function, we can find the velocity function. So therefore, the acceleration at this time gonna be equal to 47 over 2. Okay, so that's that will be our A. But remember that what's the measurements we use here? The numerator is the mileage, is the miles, number of miles. The denominator we use minutes. However, here we are asked to use the miles over the square of hours. So we have to turn this into hours. So we have 47 over 2 minutes. We turn it into hour. It's gonna be 2 over 60. It's 2 over 60 hours. So that it will be 47 times 60 over 2, which is 47 times 30. So the answer is 1410. Okay.